let's talk a bit about the, the results. Let's start with measured data. There's very little information on the methodology followed in order to be able to establish the data. There is description about flow resistivity, about atmospheric conditions, distances, and so on, but not the kind of equipment one used in methodology involved. We were able to track down some of the cases which are not presented here, and they were not used simply because they are too complicated for ISO to be used without any ambiguities. K.B. Rasmussen, the person who conducted some of the sound measurements, mentions at various points in his paper that there was uncertainty about the choice of flow resistivity. I would say that the olive tree lab terrain results have a fair match with measurements. We anticipated better results, and we believe that there was we could have achieved more if we had more information on how the measurements were conducted, simply because we have conducted complicated measurements. For instance, we carried out measurements in ancient theaters in order to establish the scattering effect of stone rows, which is again scattering is diffraction. And we had to, we went into great detail to model the theater using laser meters, and it's difficult to describe. It was hard work anyway, and yet we found out that even lateral shifts to the left or right of the source or receiver compared to the diffracting edge makes a difference, and that's not only from our experience but also from theory as well. So, why don't we go back to case 36, where we have deviations between our predictions and the results. The original results of ours were the blue curves. These are blue curves. After seeing the mapping, which represents, it was mapped halfway because it's symmetrical anyway. So, after seeing the mapping, we've seen the notch here that represents the maximum effect of the barrier, which is expected because it's any receiver at right angle, across the source, at right angles to barriers, there are two barriers there, has the maximum benefit. So we thought to ourselves, what if we were to move the receiver just a bit to the left or right to see what would happen? And the result is the green curve, which matches much better than the previous curve with the measured data. Now, a 5 centimeter error cannot be considered to be significant, especially when you know that the radial distance, in this particular case we have 4.5 meters. It's accurate, but most probably they have ignored the position of the receiver or the source, the receiver axis on the barrier. So it seems that in order to be able to come up with accurate results, one needs to have a good model. What about the ISO 98613 Part 2 results? There was consistent deviation from measured data. There is lack of detail to be able to interpret the sound propagation mechanisms involved. And the ambiguity in interpreting the standard can allow for different results. We have case 33 where we have source receiver at a distance of 4.5 meters. The receiver so happens to be in the shadow zone of the first edge, but in the illuminated zone of the second edge. If one calculates first order diffraction, we get the blue line. But if one calculates the second order diffraction, we get the red line. So it's a matter of interpretation as to which one chooses. I would conclude by saying that we know very well that ISO is an empirical method, simple in concept to be able to be understood, simple to be implemented, widely used since its publication in 1996. It has served the acoustical community very well, but it seems, in my opinion, to be inaccurate and imprecise. Advanced calculation methods offer sound waves in a 3D environment carrying information on how to lose intensity with distance, how to interact with atmosphere in terms of turbulence and refraction. Refraction has not yet been applied in our software because I think refraction is the most difficult part of meteorological acoustics. How to reflect from objects, how to diffract around and scatter from objects, and in the near future, how to lose intensity through structures. In other words, the sound reduction index. In the future, calculation methods could offer one calculation engine, because in my mind, we segregate the topics of acoustics because it's convenient for us to talk about outdoor sound propagation, room acoustics, sound transmission, because we don't want too many things to worry about. Nevertheless, nature is one thing, and it's a matter of the angle you look at it. So one engine should be able to do outdoor sound propagation, building acoustics, room acoustics, dark-born sound transmission, and many others. But they are computationally expensive. Nowadays, technology allows the replacement of old empirical methods with new theoretical models and methods. Advanced calculation methods offer better results, there is no doubt about that. But their implementation in software applications should offer more answers than questions. I think this is very vital because I heard previously that if it's precise, then maybe it's too complicated, but this is not the case. If you allow convenience in the user interface, one doesn't have to confuse complexity of the calculation with complexity of the model. Users need a better understanding of the science behind them in order to properly interpret the results. I mean, we're here and we're talking about the effects of plants, the surface and the mass of leaves. And we go into such detail, and what we do with that if we're not going to be able to make the effort to understand these things better in order to be able to implement them? In other words, in my opinion, I think we need more education. When I finished my studies at Chelsea College, I never knew anything about ground effects. Nobody told me. And I was so surprised when I found out that there were such things. I only knew about comb filtering, which is room acoustics, but comb filtering is the ground effect as well. So the other thing, those methods need to serve the user, not the other way around. For instance, harmonize, in order to calculate refraction, needs to bend the ground to do the calculations. To me, it's counterintuitive. I think there must be better ways of doing things. And we say from Mediterranean Acoustics, at Mediterranean Acoustics, the less time one needs to use a software application, the better the application is. Thank you for your attention. The question still remains. Why is ISO 9613 Part 2 the favorite method? Perhaps you might have some answers for me, or questions or comments. Thank you very much.